Hi, this is the second video in, let's call it the first unit, the introduction unit of chemistry. And in this video, hopefully short, we want to talk about chemicals, elements, and mixtures. Let's dive right in and explain what those are. So everything boils down to atoms. Now, when I say boils down, I don't mean it literally, but the expression does come from the fact that if you boil stuff, it breaks apart often. And in fact, if you heat anything up enough, it's going to break apart. If the sun is basically a bunch of elements, basic things in their most basic kind of. If you take everything apart, the most basic elements, mostly hydrogen, are just kind of in the sun, very, very hot. And so the expression boils down is not completely wrong, although I'm using it somewhat figuratively. But if you take everything in the universe and you take it apart, you take it apart, you take it apart, you take it apart, you would find that basically all stuff reduces to a finite, limited number of what are called atoms. And you've probably heard of atoms before. The word comes from a Greek who lived over 2,000 years ago, and he said, hey, I wonder if everything breaks down to some basic building blocks, that are uncuttable. That's what atom means in Greek. It means uncuttable. And so maybe everything boils down to some basic Legos, some basic fundamental ones, and you have let's say you have 100 of them, and you can take some of this and take some of this, and you can put them together, make different things out of the Legos, but they're all certain basic, components, and that's as far down as you can go. Well, Democritus wasn't completely wrong, because an atom is as small as you can get, and stuff still stay the same stuff. If you go beyond, we have discovered you can go below the atom. The atom bomb, basically split a bunch of atoms apart. That once you go below the atom, then you don't have distinct things with distinct kind of characteristics and qualities. Then you just have a bunch of protons, electrons, neutrons, and other stuff. So everything really does boil down to atoms. There are about 91 elements, an element being a type of atom, that occur in any kind of quantity in nature. Now, I guess there are another 7 that probably exist, very quickly, like in uranium. Uranium is radioactive, and you might have a little technetium hiding in uranium that you can discover if you have, freakishly sensitive instruments. Okay, maybe technically there are 98 elements that occur in nature, but 91 is the number that's more kind of normal. Now, scientists have produced up to another 20 beyond the 98, up to 118 elements by bombarding atoms with particles in these huge nuclear particle accelerators that can be like, for example, miles long in a big circle, and you send particles around and blast it into something and see what comes out. Although that's probably not the best way to make a new element, but there have been up to 118 elements that have been discovered. Now, there's a very predictable way that these elements exist. So basically, they go from 1 to 118, and they have atomic number 1 is hydrogen. It has one proton in it. It's called. Helium is atomic number 2. It has 2 protons. And so atomic number 118 has 118 protons. You don't need to know what a proton is. What I'm leading toward is to tell you that there is no other element we're going to discover on an asteroid in order to make Wolverine's claws or Captain America's shield. There is no adamantium hiding out there in some other galaxy, or there is no asteroid where we're going to find the material to make Captain America's shield. That's a nice story. It's great fiction. I love the Avengers. I love Captain America, but it just ain't going to happen, because all matter that exists everywhere is some combination of these basic, say, 98 building blocks or 91 building blocks. And so we know what elements, how they're made, and there just aren't going to be any new elements on some asteroid that lands on the Earth or meteor. So I'm sorry to say that, but Captain America's shield just ain't happening. Okay, so everything boils down to these fundamental elements. Now, elements can come together to form compounds, or things can be mixed together where they don't come together in terms of bonding with each other. Let me pause and explain that a little bit. If something is an individual element like carbon, or a set combination like water, which is two hydrogens and an oxygen, different kinds of atoms, that's called a compound. Water is a compound. Those are chemicals. If they're an element or if they're a compound, it's called a chemical because a chemical has a fixed makeup, a certain kind of makeup that everywhere you see a bit of water, it has two hydrogens and an oxygen. It has a definite chemical makeup, and that's called a chemical. It's either an element like carbon or a bonded combination of elements like water. So that's what a chemical is. A mixture, so you can have a mixture of chemicals, like you can have a mixture of compounds. Now, okay, so I have two pictures here. The one on the left is water taken out of my sink, and the one on the right is bottled water, which is, let's say that it's pure water. I don't know whether it is or not, but let's go ahead and say that this is pure water that you've paid a little extra money for, so you can have pure water that's distilled and there's nothing but the water. Okay, so the bottled water. Let's start with the pure water. Now, it's supposed to be just water. I mean, if you get distilled water. If you get distilled water, it's supposed to be just water, which is made up of two elements, hydrogen and oxygen. It's supposed to have two hydrogens for every one oxygen. So you've heard of H2O. That's basically the chemical formula for water, which basically says that every molecule of water, water being a compound where hydrogens and oxygens have bonded together. You might want to watch this video a few times to get those terms in your mind, get them familiar. So every molecule of hydrogen, of water, every water molecule, every water compound of water is made up of these little collections of two hydrogens and an oxygen bonded together. So hydrogen and oxygen, as I said, are two of the 91 building blocks or basic elements, and so under certain conditions these two hydrogens and one oxygen come together and bond together to form the compound water. So bottled water, if it's distilled water, is just H2O, bunches and bunches and bunches of molecules of H2O, bunches and bunches of a big collection of two hydrogens and oxygen here, two hydrogens and oxygen here, and so forth and so on. But tap water is not pure water. It has other things in it. Tap water has iron, sometimes chemicals like fluorine or chlorine that are meant to purify. I mean, if you go to a foreign country, if you go to certain places, when I went, for example, to Bolivia when I was in grad school, you were supposed to put some drops in your water before you drank it so that you didn't get sick, because there were little microorganisms in the water that my American body wasn't used to, and so I put those drops in, maybe fluorine, maybe chlorine, to purify and kill those organisms. So tap water is a mixture of things. It's not just water. There are other things in there. We call it a mixture because different chemicals and different elements and compounds that are not bonded together, they're just all floating around there and mixed together. So that's called a mixture. It's not a compound. It's not a pure substance. It's a mixture. But in that case, you can't see it usually. Sometimes you can see particles in water. But because it's mixed evenly, we call it a homogeneous mixture, where homo means same. So it's all mixed together evenly. So it's a homogeneous mixture. There are, of course, also hetero, which means different, heterogeneous mixtures. So here's some dirt, and you can see that there's some twigs in there. So that's a heterogeneous mixture because it's not all evenly distributed throughout. So let's summarize what we've said in this video. Everything is made up of basic elements. These are distinct atoms. There are about 91 of them. Everything you see in the universe, all stuff, breaks down into those basic elements that everything is made of. Now also, in nature and also man-made, human-made. Atoms often bond together to make compounds like water or ammonia or these sorts of things. Those are chemical. Everything I have on this screen is a chemical. It has a distinct composition, and wherever you see water, it has H2O in it. Wherever you see ammonia, it has NH4, 4 hydrogens and a nitrogen. Those are all basic elements that come together in a certain way to make a compound we call ammonia. Both of these things I've just mentioned are pure substances because they're just that, because you can have just carbon or you can have just water. But you can mix them together to where you now have a mixture. Now those mixtures can be evenly distributed together, which is called a homogeneous mixture, or they can be unevenly mixed together, which is called a heterogeneous mixture. So I hope this has been clear. We're beginning to get a sense for how to approach chemicals, how to analyze it, how to break things down. This will become very basic and helpful as we move forward.